Welcome back, Structures of Math students. This is Mr. Marquetta, and I'm here to help you with chapters 9.3 and 9.4 today. We're going to explore percents and how to use strip diagrams to figure out questions about percents, and also how to help the kids develop proportional thinking in their classroom. Okay, so first let's talk about this important word percent, and we need to be familiar with what a percent is, and we're going to throw that word around a lot, so we want to make sure that we're comfortable with what it means. A percent is a ratio. It's just a ratio. When you see the percentage sign, I want you to think it's something of a ratio. It's the ratio for which the value of the second quantity is understood to be 100. So if you say 65%, it's the same as writing 65 colon 100 or 65 over 100. The word percent, if you break it down, per means divided by, or but we all know what the word per means. And then there's cent, and of course cent means 100. So whenever you see a percent symbol, it's going to be the same as if you wrote this. They mean the same thing. And that's the way we want to look at percents from here on in and with the rest of this lesson. So we have one example that we're going to dive in and think about percents. And once again, I know that everyone here is familiar with percents. We're not learning percents today. We're learning about how to teach percents today, which is a very different thing. And while we're exploring that, let's just go ahead and jump right in and see if we can answer one quick question. Number one, this is discussion number 8. One discussion class has 28 females and 17 males. A large lecture class has 106 females and 62 males. In which class is the female population more dominant? Well, let's think right now about those numbers. Let's think about how we could figure out percentages. Now, recall that if we have 28 females in group 1, where we have 28 females and 17 males, and then over here in the large lecture class, we'll call that group 2. We have 106 females, and we have 62 males. The question is, in which class is the female population more dominant? Okay, so if you want to answer a question like that, the way we'd go about it, and guys, I'm going to just encourage you to try to make your view speaker view so that you could see clearly what I'm writing here. It'll help. In the top right, there is a little toggle, and you could change that. But we're trying to figure out in which of these two groups is the female more dominant. Well, if you take a look at these two groups, you can first think about the total of them, and we would have to add to get them. Right? And that's the total amount of people in each group. And now to figure out the number of females or the portion of females, what we would do is we would take that figure that is the number of females and divide it by 45, the total. Here we do the same thing. We take the number associated with the females and divide it by the total. See what kind of percentages we get for this, or what kind of decimals we get for this. It's just a quick dividing. And then it's a matter of knowing that you're supposed to change the decimal points a certain way. So 28 divided by 45 is going to give 0.62, which is approximately equal to 62%. And then for this one, we'd figure out that figure 106 females divided by the total, which this time is 168. And you get 0.63, which is about 63%. So now that you have your figures here, you can compare and contrast, and obviously the answer is the large lecture hall, or group 2, is more female dominated because it has 63%, whereas the other one has 62%. So writing out something like this is a good way to get students to start thinking about how percentages work, and representing percentages as just a proportion, or rather a ratio, that ultimately just has that 2 100 at the end. Again, this is the same idea as 62 to 100, like so. This is the same idea as 63 to 100. And we just want the kids to kind of see that. Okay? Very good. Okay, carrying on with the lecture. Here we have another case. Suppose you scored 15.5 points out of a possible total of 20 points on the first quiz. And then you had 59 points out of a possible total of 75 points on the second quiz. How would you figure out on which quiz you did better? So for this scenario, we're not going to need to add anything up. We actually already have the total, so we don't have to think in that direction. Instead, let's just jot down these figures and see if we can make heads or tails of them. We have the first quiz, and we got 15.5 out of 20. And then our second quiz, we got 59 out of 75. Okay, so trying to figure out which quiz did we do better on, I think we all know what to do. We're going to convert these quiz grades into percentages, and all we have to do is divide and then move the decimal point. So we're going to think about this like it's 15.5 over 20. I find out what that ought to be. I get 0.775. Which is the same as 78%. Okay. And then for the other one, I got to figure out 59 out of 75. That would be 59 over 75, which is equal to 0.786 bar. And that is approximately the same as 79%. So which quiz did you do better on? And as you can see for both of these cases, they come very, very close. The answer is the second quiz this time. Of course, that's the number that is the highest that you see there. So students may be able to answer the question by just going as far as the decimal, or students might want to go further and do the percentage. If you're trying to do an enrichment with percentages, I would encourage you to, I would have you encourage the students to do this as a ratio lesson, and then have enrichment at the end as a little percent bonus question in there. Okay. So let's talk a little bit more about percents, and now we have some other ideas and methods associated with percents that we need to be familiar with. First, a percent is a standardized way to express ratios or fractions in order to facilitate comparisons. There are three primary types of percent problems. We have the question, here's a number. This number is what percent of some other number? Then we have another question that looks like this. What number is, and then we give you a certain percentage and a certain figure and say, what number is this percentage of this figure? And then, of course, we have the case where the last thing is the variable, where we say 16 is 25% of what number? So you'll notice that these are all the same thing. This is blank is what of blank. They all are the same structure. What it's a number is blank of what number? See, its number is percent of number. So in each of those three cases, you'll see that one of the three things has been changed into the what, meaning that the variable is present in each of the cases, but in a different position in each case. Now let's use those ideas and see if we can change our word problems directly into mathematical equations so that there's never any discrepancy or confusion about what the correct method is. And we'll be also introducing the idea of equations and algebra into the lesson as part of the enrichment and as part of the everything you're doing to prepare for those tests and all the other things in the core curriculum standards. You can include that you did a little algebra in this lesson too, and that'll look good on your lesson plan. So we can keep that in there as well. So here's some of the things that we need to know about when we're changing around these three different structures of percentage questions into an algebraic equation. First, just go through each thing and look at each part of the sentence. 25 is what percent of 40? Look at each thing one thing at a time and convert each thing carefully one thing at a time. So first, numbers can remain and percents should be changed into decimals. So that means right here, this 25 will stay just the way it is. This 40 will stay the way it is. This 50 I might change into 0.50 because percents must be changed into decimals. So when you're doing a word problem like this, When you see the percentages, make sure you change them to decimals. And when you see the numbers, just keep them the way they are. Then the next thing is what can be replaced with W? What percent can also be replaced with W, but just make sure you convert it to a percent at the end. Now, I've seen textbooks use N or something else. We try to avoid using the X because X means times to the lower grades. And if you use an X as a variable and you use times as an operator, it might get a little bit confusing. And we're trying to make the kids see at the lower grades how the percentages work and throw in fractions, throw in equations a little bit. But we want to be careful with, we don't want to confuse them. So we're going to use a variable that's clearly not times, which W is a great example. So we're going to use W in these examples of how to do it. Also, when you see is, we're going to ask you to change it into equals. And when you see of, we're going to ask you to change it into times. So now you might be able to look at these three statements and think about what the associated equations would be. Like, for example, this one, 25 is what percent of 40? We're thinking it's 25 equals X times 40, or W times 40, as you see right there. Here for part B, you'll notice that what number, that's the part, that's the variable, that's the W. Is has been changed into an equal sign. 50% has been changed into 0.50, and of has been changed into multiplier times, and 60 is kept the way it is. And likewise, on the bottom here, we have 16, which of course stays at 16. Then we see the word is. Is supposed to be changed with equals. Then we got 25%, that will be changed into 0.25. Then you see the word of, that's multiply. You see what number is W. So what you're looking at, this is method one about how to answer questions about percents. It's the algebraic approach, where you take the sentences that you see and you convert them like you're translating into a different language from our language into mathematics, each thing one thing at a time. Every number stays the same as it was in the sentence. Every place that you see what is changed into W or N or a variable of your choice. Wherever you see is, you write an equal sign, and wherever you see of, you write a times sign. And then you let go of the notion of percentages, and you just focus on the algebraic part of how to solve equations like this. And what I'd like to do with you now is actually go through the remaining work of solving these equations, which I think that we haven't done that, but let's do that before we go on to the next kind. Starting with this one, 25 equals W times 40. And then you have W equals 0.50 times 60. And then I have 16 equals 0.25 times W. Okay, so let's see if we can't use our old algebra ability to solve this. And now what's happening is, for the first time, you're exposing the kids to a new idea, the opposites involved in algebra. For example, this is times by 40. So we are going to divide by 40. And when you do that, you get a new answer here. I get 0.625. That question was saying what percent. So since the question was saying what percent and the W is what percent, I have to change that now one more time and write that the answer is 62.5% now. And now the answer is correct. Let's carry on to the next one. To solve this, all we have to do is just some computation on the right. 0.50 times 60 is going to be 30. So now I have W equals 30. That was pretty quick and easy. Notice that this question read, what number is? So the W is a number, not a percent. So we're going to leave the answer just the way we see it and not convert it into a percent. Here also, we are asking about what number, and the percent is not what's being asked, so we won't be converting. Again, we have a multiplication on the right, so we're going to use the opposite operation, and we're going to divide. And you should get 64 there. Let's see, 16 divided by 0.25. No, that can't be right. 16 divided by 0.25. There we go, 64. Okay, so this is how you would do a percentages question algebraically, is you would change each of the things like we explained with our little legend or key. Is equals, of is times, W is what The other numbers stay the way they are unless they're percentages and you change them into decimals. And then you have an equation and you abandon the idea of percentages and you just focus on the algebraic approach and solve it like an equation and get your solution. Make sure when you're done now, if it was a percentage, that you convert it back to a percent. And don't rely on the idea that this must be a decimal in order to do that. Oftentimes when you're doing these numbers are awkward and they're deliberately awkward to try to test to see if you know. But it's not just about the decimals get changed, it's about the answer gets changed when they're asking what percent there. The second method we're going to talk about is how to use strip diagrams to answer questions like these. And when you're using strip diagrams to answer questions, you have to draw the same kind of strip diagram every single time. The last couple of strip diagrams we were using had to do with multiplication and division models and addition models. With fractions, these are going to be a little different looking. They will be vertical rectangles and they're going to represent quantities. I want you to think of them as if they're beakers in a chemistry lab and you're filling them with water such that they go up as the water level goes up as far as a certain amount. And quantities are shown kind of that way as if it's a filled up rectangle. Okay, so first you're going to use a vertical strip and it will always represent 100% every single time. Then you're going to cut that strip into pieces to represent pieces of the 100%. And every time that you write a cut, you write the percent on the right and you write the value on the left. Here's an example of what it looks like to use a strip diagram to answer questions about percents. For our first question, we're asked, and it's over there in the corner upside down, we're asked 25 is what percent of 40? Or I think this one is going on B right now. Yeah, right now you're looking at the answer to part B. And I think I'd like to start that over again. Let's see that again. We're asking question B. I was a little bit confused. I thought this would be A, but we're starting with B. What number is 50% of 60? So we get a strip diagram in there. There you go. Notice that the strip diagram will always, always, always represent 100%. And this is something you'll always rely on. 100% always goes on the top right. On the left, we have the number that is associated with the percent. In this case, the whole in the story is 60. So 60 and 100% are the same quantity. And notice on the left side, we have a 60. On the right side, we have 100%. Now we include the idea of 50% and think about what 50% means. And that's what happens when you draw a dotted line, something like this. I'm trying to express that I understand that half of this strip diagram is 50% of 100. And in the same connection from 100 to 50, what did I do? I divided by 2. I can take 60 and divide it by 2. And that's why I can assume that 30 is what goes here. Now, once again, sometimes when you look at these new methods that you may not have seen before when you were a student, that doesn't necessarily mean that they're ridiculous and completely unusable. Some of them may be. Some of them you might look at them like this strip diagram and say, I don't like this approach at all. I would never teach this in my 4th grade class. Then again, maybe you feel like you would. I'm asking you to learn how to teach it in the event that you'd have to teach it, or that you were co-teaching with a team, or that you were in a department where they were using these strip diagrams. I want you to just try to embrace it and understand how it works. It may not necessarily be your favorite kind of math, but it is a different approach, and we have to keep an open mind, my friends. Good teachers have open minds. So try to understand how this works, and you'd be surprised. You might find this to be an easier way to do percents than you did before. I've had students come to me and tell me that when they took the praxis, which I help a lot of students with the praxis, but when they took the praxis, they actually used this method when they were doing percents, and it helped them much more than this old algebraic method that they learned back in 6th and 7th grade. Because most schools do include this in their 7th grade math curriculum or their 8th grade math curriculum. Okay, so once again, how do we deal with this? We start in the same way every time. We draw our strip diagram. After we draw the strip diagram, we put 100 on the top right. We put any numbers that we can on the left to represent 100. And then we think about the other numbers and show chops and dotted lines and cutting like that. Let's do a couple of examples like this, okay? Okay, now first what we're gonna look at is part A, and then when we're done, we'll take a look at part B and discuss part B, rather part C. But right now, let's focus on part A. In part A, it says 25 is what percent of 40. Now I wanna start by bringing your attention to this rectangle right here. This is my first strip diagram. And students may draw successive strip diagrams, maybe 1, 2, or 3, many of them. And that's okay. It's up to you how you do it, as long as you get the correct answer. It also does help a lot if, as an instructor, you already know the solution. I know it's going to be 62.5%. And you may discard this one because it's got the decimal in it, because you might find it to be a little bit too tricky, but it still does work with the strip diagram. And it is a great example for us as teachers to explore. Starting with, let's figure out if we can do 25%, 25, and how it compares to 40. Notice that once again, 40 is going to be the whole. So on the right side of the strip diagram at the top, I write 100%. And on the left, I write 40 to represent that these two quantities are the same, and they are both the entire rectangle, and they represent one whole. Next, to get to 25, you'll notice that what this student did was this student went from 40 down to 20, and then went halfway in between to get 30, and then went halfway in between again to get 25. The way you would do that is draw another rectangle with all the same information that you had, just copy it. And now talk about your next step, which is instead of cutting it in half to represent 50% and then 40 to 20, I'll cut it in half once again, knowing that between 150 is 75%, and between 40 and 20 is 30. Again, it's abstract thinking, and different students will think in different ways to get these answers. But you can see there is a thought process here, and students can show their work in this way with a little bit less algebra and a little bit more drawing, which is really healthy for them. Also, we can get in between 20 and 30 now if we cut exactly between them. So between 20 and 30, we have 25. And if we average 75 and 50, we'll get this awkward 62.5. Or if you think long and hard about it, you might come to the conclusion that 62.5 is exactly the same distance away on the number line from 75 and 50. So what we came to our conclusion, 62.5, here's our work. It's all these strip diagrams. I'm going to ask you, my friends, to go ahead and give it a shot now. I want you to see if you could use the ideas that we just discussed with strip diagrams and use this example to try to do something with this one, part C. I'll give you a hint. 16 is not the whole this time. The whole is greater than 16. And I'll give you another hint. I think you already know. The answer to this question is 64. We did already finish this. So keep in your mind, guys, while you're trying to construct a strip diagram on a piece of paper, that the answer should come up being 64, that 16 is not the whole, and that you're going to just try for the first time to sketch a couple of rectangles and see if you can come up with something that looks kind of like this. I'm going to give you 15 minutes, and in that 15 minutes, you can also take a little break at this point. Right now it's 8:37. I'm going to ask you to please return to class, my friends, at 8:52. And at 8:52, we'll reveal the answer, and we'll carry on with our discussion of strip diagrams and percents. Okay, and carrying on with our discussion about strip diagrams and introduction to percents here, we are talking about the idea of part C there, where we're saying 16 is 25% of what number? Now, to try to come up with a strip diagram, of course, first we draw the rectangle, and the first thing we do is we put that 100% there. So now that the 100% is there, I'm going to put a question mark here because I know that the ultimate question is what number, And if I begin by thinking about what 25% is as it's related to 100%, I could put that down here next. That gives me and knowing that 16 is 25%, that gives me the idea to put the dotted line and put 16 here. So the first thing you would do is put the 100%, then you would put the question mark, thinking that, okay, I recognize what the whole is. I don't know the whole, but I know 100%. And then also down here, the statement that 16 and 25% are the same, knowing that 25% is approximately a fourth of 100, or well, it is a fourth of 100, kind of putting it down here to represent the smaller part of the rectangle. And now putting 16 here, you have two connections. You have the connection that you can divide by 4 here, or you can multiply 4 to go up. Looking at it here now, to figure out what that number must be, you could go up from 25% to 50%. If you double it, you'll get 32. And then if you want to go from 50% to 100%, you can double it again and get your 64. So it's kind of a funny way that it's written, guys. And I know that when you're looking at it, you might feel like, how am I supposed to know that? If you can look at the way that the kids draw the rectangles and make sense of the one step to the next, how it's working, and use your own methods when you're explaining it and giving examples, I would encourage you, if you were going to teach this lesson, to do a couple of examples on paper before you did it, to think about how it would look. Maybe model these and make these a structure that's modeled over and over again, like using things like 25 is what percent of 40. Do other things that are very similar to this, where you wind up cutting it in half and cutting it in half again, and use that as bank A. And then use this as bank C, where you have a smaller percent. Like you can use 25%, you could use 20%, you could use 10% here, and it would be the same kind of ideas. And you could use any number here. So these are the general structures of how the strip diagrams work. And I want you to be familiar with how to do them. And that's why we do have practice associated with this. I did not post the activities yet for this section yet in our e-learning Blackboard, but we do have our WebAssign practice open and available. And I will be encouraging you to try to work on that between now and our next class as well. Again, you have plenty of time to do it. I think I made the due date the 15th. It's far in advance. So you have plenty of time to do it. And if anyone needs an extension, let me know. But the strip diagrams is something we have to start thinking about and using while we're teaching in the classroom. So let's see if we can figure out a couple of cases here where we do a strip diagram, and we also do it with algebra. And I'd like to show you both ways for these situations, okay? Starting with this example number 7. In a case like this, we're asking first to examine the question and kind of analyze it. And we're going to use these important words. One of them is base. And generally, the base is the percent. Take a look at the way this is written. It says, for a problem in which there is a percent increase or decrease, knowing that the base is the starting quantity helps to determine how to solve the system. So the base is not necessarily percent. In this case, the base is the percent, but it's not always the percent. To be honest, usually looking at it, it almost always does turn out to be the percent in the questions in WebAssign. And you have 100 attempts in WebAssign to answer over and over again to see if you got it right yet. So I would kind of always lean toward thinking that the base is the percent. So in this question, a company announced that it's increasing its workforce by 50% or 30 workers. How can you tell how many workers will be in the workforce after the increase? 15% is considered the base. Now that's what this textbook says. Other textbooks are going to look at this and say, no, it's not. The base is some other number that I don't know, and 15% is on top of the base. It depends on what textbook and what grade level you're teaching. The word base is kind of used interchangeably. I just want you to have a solid education on how this stuff goes through when you're teaching it. Sometimes you'll see the word used in other ways that kind of conflict with what other textbooks say. Here we're saying that the base is going to be considered 15% in this kind of lesson. We can answer the question and think of it as being 230 workers because we have to think about some other number such that if I take 15% of that number, it becomes 30, which means that we're going to come across another weird question that looks like our algebra stuff. The question that actually does show up is 15% of what number is 30? So the answer, we already know what the answer is. The answer is going to be 230 because the answer is actually 200 to this question, and 200 plus that last 30 is going to be 230. But what we're hoping we'll do is notice that 15 is considered the base this time. And the reason why it's the base is because looking at this wording, it's the most important thing. It's like the primary noun or subject of the sentence. It's the first idea that they're throwing at you. Maybe that's why they're calling it the base. The point anyway is when you see that question about the workers and all that whole story, and there's percentages in it, we want you to find a way to help the kids reduce a big word problem like we saw into something very basic, like one of our 3 structures that we're familiar with, that we learned earlier on. This is the structure that we discussed where we have a number, and then of, and then a number, and then is, and then a number, or vice versa. And we have 3 quantities, one of them missing, one of them being a percent. This is now a new question where students can either do it with algebra or with a strip diagram. Let's do this one with algebra. If we're going to do this with algebra, we're going to change 15% into 0.15. We're going to change of into multiply. We're going to change what number into W. We're going to change is into equals. And we're going to change our final number into 30. We're going to keep it as 30 because numbers stay the way they are. Now to finish up, we consider that W is connected to this number with multiplication. So we use the opposite, which is division. And we divide both sides. And then we get the calculator. And we figure out 30 divided by 0.15. And I get my 200. Okay, and now one last thing that we have going on here is, of course, the question is, well, then how many are there at the end of the story? Well, at the beginning of the story, there were 200. Then we added on 30 more. And then, the student has to now think about this idea for a minute and give the final solution to be 230 people as a solution there. But the point anyway is that we have found a way to change this number, this whole situation into an algebraic approach. Now, if you wanted to, we could try to do other things, like say, for example, we did with a strip diagram. And try to answer this question again by using a strip diagram. If we wanted to use a strip diagram, it might be something like this. We're going to draw a strip diagram, and we'll put 100% right here. Now, for this case, do we know what the hole is? No, we don't know what the hole is. We know that there is a hole, and that 15% of that hole is 30. So I know that 15%, which is down here somewhere, is 30. Now, you could go in a lot of different directions to try to figure out what this is right here. Maybe you can get this if you first add it on twice and get to 90. And then maybe you could add 10% of it, or you could just find 10% of it and multiply it by 10. There's a lot of ways. I'm going to think right now about 5%. And 5% ought to be 10, right? Why would I think of 5%? Well, if I could think of 5% being 10, then I could argue that 20% right, ought to be 30 plus 10, which is 40. Why would I do that? Well, if this is 20%, I could do 20% times 5 is 100, right? Okay, well, what's 40 times 5? 200. I bet you didn't think that was going to work, did you? The strip diagrams actually, when you start playing with them and daring to try to use them, they do actually kind of make sense. You start to see reasoning that you didn't see before. You start to see quicker and easier answers and things that make sense and are more practical that you didn't see before. You could also have, if you wanted to, change this strip diagram into a different idea. Say instead, here's another way to do this strip diagram. Again, every strip diagram always begins the same way, just like that. They always begin with a rectangle and 100% over there. What if we went with the idea that they told us right up front that 15%, like we said, 15% we know, 15% is given as 30, we already know that. But what if instead what we did was we recognized that if we take 15% minus 10%, 50% minus 5%. Okay, try to follow me here, guys. It's kind of deep. But if we know that 5% is 10 and we subtract, we get 10%, right? So if we subtract these, we get 20, meaning that 10% is the same as 20. And if 10% is the same as 20, right? If 10% is the same as 20, then I can relate 100 and 10 by doing times 10, right? So let's do 20 times 10. And that's what you're looking at is 200 there again. Both of these are appropriate strip diagrams to try to show the idea of how to find a percentage question like this. And I'm almost certain very few of you have seen something like this before. I invite you to try to open your mind and think about how it works. You might be that only teacher that brings this across. It's very impressive to be able to help students learn in a way that other teachers haven't before. This is a great way to try to get your ideas across. And you'll see this in the textbooks, and you'll see this in the PowerPoints that they give and all the other materials that are associated with the core curriculum standards and everything. But this is strip diagrams, and you got to try to use it to help the kids learn a little bit with the percentages. Okay, guys? Let's look at the next case. In this one, once again, we're asking you to identify the base. The question reads, the town's budget is now $3 million. That is 25% more than it was last year. What dollar amount was last year's budget? Okay, so let's just jot that down. The question that we're being asked right now, the town's budget is now $3 million, and it's 25% more than last year. So there's some number that when I did 25% of it and added it on, I got 3 million. This example, let's take a look. We would do something algebraic kind of like this. Now, the reason why I would do it this way is because in the same way that we had things like percentages where we say 25% of some quantity is 3, you'd say some quantity what you're looking at is a model. This is a structure that's using a model. This is a good way to figure out something like this. Some quantity plus 25% of that quantity, which you could find by multiplying that same sum quantity equals 3, right? And the reason why I'm putting it this way is because when you read the word problem, it's not really very clear up front when you first look at it how that works. But whatever it is, this quantity, 3 million, is some other quantity plus 25% of that quantity. We could also think about algebra, how you put a 1 in front. And if you combine these two like terms, you would just add their coefficients. And we should have 1.25 n equals 3. This is the algebraic approach I would use for this one. So if you're doing a question where they have a comparison and the base is 25%, but it's not as straightforward as something like this, where you could use a strip diagram or a basic structure, I recommend to go straight to your algebra skills and try to use this as your more advanced lesson after you've gone through with the kids how to do the more basic ones with the 3 structures we showed earlier. Maybe now it's time to involve this with the students when they're ready and when they're in that position. Of course, we would go through dividing, and remember the word million is here as a label. So it's going to be 3 divided by 1.25, which is 2.4. So n is 2.4 million. And we have another example here now. For a problem in which there is a percent increase or decrease, knowing that the base is the starting quantity helps to determine how to solve the problem. So for example, 9, we're saying one school had a decline in enrollment of 12% and now has 352 students. How many students did the school have before the decline? This is a great example of a strip diagram situation. I would use a strip diagram in this case like this. 100% is always in the top corner there. And we're telling you that 12% has decreased, right? So if 12% has decreased, then I guess that means this is 88% here, right? I'll put a little note, 12% decrease. And that amount is 352. Okay. So if we're going to try to figure this one out, we're trying to go from 88% up to 100%, and we're trying to go from 352 up to 100. Now, how can we go from 88% up to 100? What can we do? How can we go from one to the next? You have to think about it. You have to try to find a way to get there with it, and it's a little tricky. But one thing that I do notice that's in here is that the difference between here and here is 12, and we might be able to find a way to get to some basic amount by reducing down. Another way that we could do this is we could think about how this is x, and we could use a proportion concept. We're going to revisit this one when we come back next time, and I want you to take a look at this one and see if you can come up with a solution using the strip diagram. Also, read up on it in the textbook and see if you're familiar with that procedure. When we get together again on Tuesday next week, we'll start our lesson with this one, and we'll talk about how you could go about getting from 352 to whatever the value is up there using the numbers 88 and 100. I want you to try to look at it. I know it's confusing. I know it's challenging, but I need you to try to think about it. When we get together next time, I'll show you a couple of different ways to go from 88 to 100, but it won't help if I just start telling you. I need you to try. Okay, so we'll talk about that on Tuesday next week, and that will be the beginning of our lesson. As a sneak peek, if you take a look here, it might look something like this. There are other ways besides this to do it as well. You could go all the way down to 1%. The last thing I'd like to share with you guys before we dismiss for today is the important ideas that are associated with proportional thinking. And those ideas came directly from an important educator whose name is Susan Lehman. And I want you to be familiar with these ideas because like Madeline Hunter and all of the other important educators that we try to model ourselves after as good teachers, we have to learn what their ideas are and try to adopt them if we like them or reject them if we don't. And here's another set of teaching ideas that I think we all need to discuss and think about. There will be 1 or 2 questions on your exam associated with this material. So let's go through these ideas before we dismiss today. Number 1, the ability to think in terms of unit rates and multiple units. These are the characteristics of proportional thinking. We need our students to be able to do these things, to think in terms of unit rates and multiple units. Remember that a unit rate is a ratio that has 1 as its second thing. More efficient problem solving, that they can think about problem solving. And then we have regular use of partitioning, meaning that often they're drawing diagrams like this and drawing and making connections and cutting them into parts and things like that. Finding unit quantities, which means finding the amount for exactly one and only one item. Then we have the ability to think flexibly with fractions and decimals. This is a big one. Most of the students really kind of freeze when they see any fractions or any decimals, they just freeze. We have to find ways to get the kids to be able to use fractions and to be able to work with them. Let's be gentle about that because kids have trouble with that, and the more kindness you can bring into that, the more progress you'll get with the students, especially with those topics that are challenging like fractions. So we want them to be able to get as good as fractions as they can, including being able to do it mentally and also to do mental math with decimals and percents. And also Susan Lehman carries on with being able to identify everyday situations where proportions are not useful. And then the ability to solve both missing value problems and comparison problems using reasoning. So Susan Lehman has a very strong connection with all the different topics we're studying here, including the strip diagram, including the percentage questions, everything associated with ratios and unit rates and so on. And we want to be familiar with her ideas. And these are the characteristics of proportional thinking according to Susan Lehman. So please commit them to memory, study them, explore them, get comfortable with them. And we'll see you next time in class. At this point, we're just about through with class. Let me come back on and say, and give a formal farewell. Thank you so much, my friends, paying such close attention to my lesson. I sure do appreciate it. And I just want to make sure that everybody's comfortable with the material. And if anyone has any questions, let me know. We're officially dismissed now. I did take attendance on the break. I didn't tell you that I did, but I did. I took attendance on the break. And, we're officially dismissed. I'll stop the recording and then we'll open the floor for questions.